Hi guys, welcome to Math 135. This is the first day that we're actually learning anything new. Today we're covering the very first section, section 1.1, and it's about the coordinate plane. Now we're kind of assuming that you have at least a little tiny bit of familiarity with the coordinate plane. It's also called the Cartesian coordinate plane. Let's highlight that. Where's my highlighter? There we go. It's called the Cartesian coordinate plane, named after this really famous mathematician Descartes. And I guess the story goes he was like sick in bed or something. He's looking up in the ceiling, looking at the tiles and trying to try to figure out how to communicate where a fly was landing. I think I have the story mostly right, something like that. And he's looking at like the horizontal and vertical lines and trying to pinpoint where the fly was based on that. So that's kind of the story behind Cartesian coordinates. And there's two main things that we're trying to learn today. Let's see if I can switch the color of this highlighter. So number one, how to find the distance between 2 points. And we'll do that using the distance formula. I'll explain where that came from in a bit. And then number two is how to find the midpoint between any 2 points. And I'll explain the theory behind that as well. All right, let's start with the first topic. First topic is the distance formula. And to start, I'm going to give you just a little bit of the background, show you the formula, but then I'm going to show you the justification for it. And I think this is really honestly one of the most interesting things personally, the distance formula. Okay, it says distance formula. It gives you the distance between 2 points, x1, y1, and you know x1, y1. X part is the horizontal distance, y is the vertical distance, right, from the origin. x2, y2 is a different point. x1, y1 for the first point, and the little subscript 1 is to tell you that's belonging to the point 1. And then the little subscript 2 tells you that's belonging to the second point. So here's the formula. It says the distance, this little d represents distance. It's saying the distance between these 2 points is given by this formula here. This big ugly thing. It's actually not ugly. It's actually quite beautiful if you ask me. But I'll tell you where it comes from in a moment. And alternatively, sometimes we just write d for the distance. So two alternate notations. This one here, this d is a function. It's telling you if I give you 2 points, it's going to spit out the distance. And sometimes we can think of that distance as being the distance d. It's just like a fine, language thing. It's really math is a language, so we're getting used to how to communicate. This formula here is the exact same formula that you see right above it. So these two guys, exactly the same. All right, now let me just kind of briefly go over what that description says down below. It says, you could just memorize it. You could, but I think it's more helpful to understand why it is, what it is, and it all comes down to the Pythagorean theorem. Here I give the explanation down below. You can read that on your own. You can even pause it and read it to yourself, but I'm going to give you the explanation with a visual right now. So let's look at the distance formula. Okay, I'm going to get a sheet with some grid lines on it. Okay, so there we go. Just waiting for it to straighten out. Okay, so the what do you call? Start again. Just make that on the line. That's better. So the Cartesian coordinate system, right? You've seen it before. It's just like 2 lines, one horizontal, one vertical. This is called the origin right at the center. That's the position 0, 0. And then as you go along the line in the left or right direction, those are the x values. So we call that the x-axis. So this would be like +1, +2, -1, -2, right? And then the up and down is called the y-axis or the vertical. So this would be like 1, 2, -1, -2, right? Okay, so let's look at an example for the distance. Let's just pick 2 random points. Okay, I'm going to pick 2 random points in this first quadrant because that just makes it simpler to understand. So let's say my first point is right here. That's the point 2, 1, right? So in other words, your 2 would be the x1 coordinate and 1 would be the y1 coordinate. Okay, let's get another point. Let's say, I don't know. Let's say this point right here. This is just random. This is the point, let's see, 1, 2, 3, 4, 5, 6. So the x coordinate would be 6, and then the y coordinate 1, 2, 3, 4. Y coordinate would be 4. So here's your x2, right, is the 6, and y2 is the 4. Okay, so what I want to know, what I'm curious about knowing is, what is this distance from point 1 to 0.2. And the shortest distance is a straight line, right? So what I'm asking for is, what is that purple line? How long is that purple line? And how would you figure it out? Well, just think for me from the very beginning. Let's say you didn't know the distance formula. How could you figure that out? Well, one obvious way is to complete this triangle here, a right triangle. Oh, good job writing that straight, guys. Okay, and this is a right triangle, right? Well, if it's a right triangle, then to figure out this point, this distance, we'll call this distance C, then I can use the Pythagorean theorem. If this distance here is A, this distance here is B, then I can use the Pythagorean theorem and figure out what C is. Because, as you're probably familiar with, A squared plus B squared equals C squared, right? That's the Pythagorean theorem. A squared plus B squared is equal to C squared. C is the guy that we're after. So if I want to know what C is, I take the square root of both sides, right? And then I get C is equal to the square root of A squared plus B squared. So this right here, this looks very similar to the distance formula if you think about it. Let's reverse the order so it looks even more similar. So if I switch that, I'm just gonna switch the left and right side of that equation. Then I'm gonna get C is equal to the square root of A squared plus B squared, right? Now it's looking very like the distance formula. If this C happened to just be called D, then it would pretty much be it, right? And what's this A squared? Well, how do you get A? Well, A, this distance here, it's a horizontal distance, right? Here, let me clear some of these guys out of the way so that it's easier to see here. So I'm gonna move these guys out of the way for a minute. Just kind of clear up some space so you can see what's happening more clearly. And let's zoom in here. So how do you find this distance here of A? Well, it's just the x coordinate over here minus the x coordinate over here. That would be the distance, right? So you could call that whatever the x2 was minus x1, or equivalently x1 minus x2, because just one of them will be negative, one will be positive. But if I look at my formula, it doesn't matter because I square it anyway. So it's going to become positive either way, right? So what is this? What is this distance? Okay, let's look. This is a position 6, right? This is a position 2. That's the x value. So A is going to be 6 minus 2, or 4. This is 4. And how did I get that? I got that by taking my x1 minus x2. Well, that would give me negative 4, but if I square it, I get the same result anyway. And then over here, I'm sorry, guys. I'm probably confusing you by using the x1, y1, x1, x2. Let me just use the actual numbers here first. So x1 was 2, right? And x2 is 6. And then I'm going to square it. Okay, over here, what's this b distance? Well, it's whatever the y coordinate is here minus the y coordinate there, right? The y coordinate up here is 4. Y coordinate down here is 1. So 4 minus 1 gives me a distance of 3. B is equal to 3. It's a gap between those. So looking down here, let's see, make it so we can see everything. That's let's see, x1 was actually the smaller one, right? So 1, and y1, I meant y1 was 1 and y2 was 4. So 1 minus 4 and then squared, right? And then square root it. That's going to be equal to C. So you see what happened? We took the x1 minus y1 and x2 minus y2, and then we squared it. Sorry, my family's sending me pictures. Stop it. I'll turn off my notifications for the next video. Okay, so then we keep that square root symbol. C is equal to all of that, right? So just recapping, what do we do? How do we figure out this distance? We just applied the Pythagorean theorem, and then it led us to this formula. And then really all the formula is, let's kind of bring it all together. What is the formula? The formula said on the first page, the distance is the square root of whatever your horizontal distance was, squared, plus whatever your vertical distance was, squared. And that's all. That's the distance formula. All right, guys, let's come back to the notes now. That's all. That's all. We just explained this portion right here, right? Or equivalently, this portion right here. That's the distance formula. Okay, so with that in mind, we're gonna try it out real quick. In this first video, I'm just gonna finish one example problem with the distance formula, and we're gonna apply it to problem 1, part A on the back page. So where is the back page? That's down over here. Okay. Problem 1, part A. Part A says, find the distance between the 2 points. Part B will be the midpoint, but we haven't talked about that yet. Okay, so what I'd like you guys to do, and this is part of your classwork, right? Classwork is for you to submit the answers to all these questions. So give it a shot right now. If you want to pause the video, or if you want, you can wait to the next one and just use this as an example question. And then from the next one onward, you can try it out and then watch the solution. I'm always gonna tell you the answers and show you exactly how to write out your work, but I'd like you to just get used to trying it out and give it an honest attempt before you watch, generally speaking. But for this first question, you can just watch it so you can use that as an example. Okay, so here we go. So I'm looking for the distance between these 2 points, -4, 1, and -7, -9. Oh, sorry, that was ugly parentheses there. Okay, the distance. What's the distance formula tell me? It tells me, okay, then I should take, this is how you should work too, by the way, right? You plug it in. The distance between those 2 points is going to be the square root of x1, which is -4, minus x2, which is -7, so minus the -7, right? Squared, plus x2, which is 1, I'm sorry, y1, I mean, y1 minus y2, which is a -9, whole thing squared. So showing your work, this is the first step you need to show. And then you can take one more step to simplify and then the final answer. Now this calculation, you can use a calculator for it. So don't worry about, arithmetic. Arithmetic is not really our focus here. -4 minus -7 though, that would be the same as -4 plus 7, which is a +3. So I got +3 squared. Plus 1 minus -9 is the same as 10, +10 squared. Right? So I got 3 squared plus 10 squared, which is square root of 9 plus 100. I got the square root of 109. And that's part A. Right there. Looking at it, it's 109 square root of 109, simplify, and I don't see any factors of 109, so we'll just leave it as the square root of 109. I think your calculator should actually be able to simplify it for you automatically as well. Okay, anyways, guys, that was the gist of the distance formula. So in this first video, we covered what that main formula was. That means we learned really number 1 of 2 topics for today. In the next video, I'm going to cover the midpoint formula, and then we'll try problem 1 part B as an example. And then that will be the end of those 2 videos. In the videos after that, we'll go over all the questions. Actually, no, I take that back. There are applications, so some videos will be applications, some video will be questions. All right, let me stop there.